The evil twin attack exploit focuses on kicking end users off of their main network, posing as a legitimate one for end users to connect to so we can phish sensitive credentials from them using a series of complex techniques such as DNS poisoning, ARP poisoning, and jamming attacks. I'll cover a bit about what those are later on throughout the presentation. This exploit is also what is known as a rogue access point. I'm also going to talk about why it's so strong and what it's capable of bypassing, as well as overall web application security. Typically, this is done using something that is known as a Wi-Fi pineapple from HackFi. But we're much better than that. You shouldn't have to rely on someone else's tool to get the job done and should be able to perform the exploit without the tool. Being able to do so demonstrates you truly understand how the technique works. I'm going to show you how to perform the exploit without one and the raw natural science behind it. What is a Wi-Fi pineapple? The Wi-Fi pineapple is designed to masquerade as a legitimate network access point that tricks end users into connecting to it, posing as the exit node on the network while routing the victim to a malicious site, whether it be locally on the network or externally via a hosted domain by the threat actor. It utilizes DNS poisoning to pull this off. It can also tether to a legitimate network to avoid detection while stripping all credentials and routing them to the legitimate one after the stripping occurs. What you'll need for the exploit. This little toy here, the SanDisk wireless flash drive, is one of the best unintended hacking tools that you could possibly own. Why? Well, it's a wireless access point you can connect to and share files over to save stuff too. You can also practice network penetration testing on the go with this and do whatever you want. The default gateway also has all HTTP methods allowed so you can practice hacking on them. And it also allows you to daisy chain to a main access point just like the Wi-Fi pineapple. It's also great to practice Wi-Fi hacking on seamlessly since it doesn't randomize the frequency channels for it. We'll be using this as the victim network to create a twin of. It has a lower PWR, which we'll need for the exploit. You'll also need the Alpha AC1200 NIC card that is listed here as well if you want to kick them off the network via the authentication packets. You can also try your main system, which I'll be doing since most standard NIC cards in all systems today tend to be capable of sniffing wireless data packets based on IEEE standards. The main issue with this is if you haven't upgraded to the latest version of Kali Linux in terms of the 2024 edition, you'll notice there's a bug in the Aircracker G Suite where it won't allow you to do so with the base NIC of your system, even if it's capable of sniffing data packets. Older versions of Kali, like the 2019 version, for example, do not have this problem. What is an evil twin attack? Using this diagram, I'll walk you through on how the exploit works step by step. It shows the overall scheme and flow of the exploit. The top right part is the victim, followed by the legitimate access point they're trying to connect to below them in yellow. The top left part is the attacker, followed by a rogue access point below them in red that they have set up to intercept and trick the victim into connecting to it. It shares the exact BSSS ID as the original one and typically jams the original so that only its name comes up. This can also be useful if the end user auto-connects to networks, which bounces them to theirs. Next, the victim will try to connect to the real access point, but instead will connect to the rogue one, bringing them to the spoof gateway portal to authenticate to the network to access the internet. Since these typically use HTTP and not HTTPS, it makes it harder to tell the difference between the real one and the fake one. Now that the victim is connected to the rogue network, as they browse the internet, the traffic they send will be stripped by the threat actor, forwarding them copies of any and all central credentials they sent over. The entire process will act as if it were a real access point, where the end user won't be aware of what is happening the entire time. What is DNS poisoning? DNS poisoning is similar to a technique known as ARP poisoning, where you poison the ARP cache of a network or switch gateway device in order to receive copies of what other systems on the network are sending to and from the network. You'll need both of these techniques in order to perform the exploit. We are spoofing and manipulating the DNS routing that is set in place in order to redirect the end user to malicious sites of our choosing. DNS occurs on port 53 and is what the default gateway uses in order to handle and route network traffic on your behalf while browsing the internet. What we are going to do in this case, for demonstration purposes, is set up a rogue access point that will have a system on the network acting like the default gateway, where it will poison both the victim and the AP itself, routing them through two fake sites to phish sensitive credentials from them. This is a visual representation of what DNS poisoning also looks like. The end user will enter in the URL address into the search bar, such as google.com for example. This will be forwarded and handled by the default gateway, the router, which will query and forward the URL destination on their behalf. The attacker, who's poisoned the DNS cache, will sit on the infected network and then proceed to redirect the end user to a malicious site that spoofs the original, stealing any credentials in the process. Once the end user is directed to the spoof site, typically it will redirect the end user back to the original as if nothing ever happened. What is ARP poisoning? Essentially, you are masquerading your IP and MAC address on the internal network as another system in order to receive copies of any network traffic data intended for it. When you communicate on the network, whether it be internally, the local network, or externally, a web server, the default gateway, your router, handles the communication for you and routes it on your behalf. When you receive a response, it also handles and forwards that information to you as well. If you masquerade as another system on the network, the default gateway is essentially going to send you a copy of the return information for the victim as if you were them, exposing any sensitive credentials in the process. This methodology is what is also known as a form of man-in-the-middle attack. A man-in-the-middle attack is when you intercept a communication for one or more parties involved and either steal or forward that data, manipulating it as if you were the original sender, unsuspected to said parties involved. It's also possible to intercept stuff like HTTPS using SSL strip. Let's go over how ARP poisoning works via the diagram shown to the right. You have two end users, Bob and Mary, whom are communicating with each other over the network via the default gateway/router located in the center. Each time they send a message to each other, it's routed through the default gateway and sent to its respective destination. The attacker sits on the network as well and poisons their IP and MAC address so that when the router responds with the reply to set destination, the attacker will also receive a copy in the process. It's possible to spoof more than one IP/MAC address at a time using tools like ARP spoofs, for example. What are jamming attacks? Jamming attacks jam the signal of the original access point so that victims on the network can only connect to yours when they attempt to re-authenticate back to the main access point. It causes a form of radio frequency interference that prevents the main access point from allowing end users to connect back to it. This technique exploits PWR transmission frequency output levels, which control the strength of the overall connection for the access point as well as range output. By having a road access point that is stronger than the target one, we can jam it and then force end users onto ours. This is a common technique that is used to breach access points, more so ones that have stuff like channel frequency randomization set in place, which prevent threat actors from honing in on the access point BSS ID channel. This diagram will demonstrate how jamming attacks work so you have a clear visual understanding of what is going on during one. The threat actor within the vicinity of the target access point will set up a rogue access point with the same name as the target network. Next, the threat actor, us in this case, will send the authentication packets that will bounce end users off the network. Because we have a higher PWR, the end users will auto-connect back to our network. When the end user tries to reconnect, they will be redirected and auto-connected to the rogue access point. Since the rogue AP is passwordless, it will simulate as if they are just reconnecting back to the original network. The exploit. For this part, sit back and relax. I'll be showing you how to pull off the exploit live. This is a demo of the full 43-minute live that I have up on my Patreon. Now, let's begin the demonstration. We're going to pop into our top shell and run iro-dump-tac-ng so that we can scan for our target access point for type of webs. This will allow us to secure the BSS ID of the system, the frequency channel, as well as the MAC address of the network. Next, we're going to pop into a side-by-side view of the victim, my mobile device on the left, followed by the attacking system on the right. So you can see us kicking the system off the network using airplay-tac-ng to send the authentication packets. As you can see, we begin sending a total of 100 deauthentication packets to force our mobile device onto our rogue network, which is taking in as effect as you can see it trying to reconnect back to the main network over and over again. The rogue one is the secure one with a lock on it, followed by the target one being the insecure one. This is so we can easily tell the difference. Give this a bit and we'll see the results. Now the victim is connected to the rogue network, we're going to check the IP for it, which we'll need in order to poison it. I'm using the Termux emulator for this process. Next, I'm going to configure the host configuration file of my attacking system so the victim gets routed to the spoof gateway portal when they try to authenticate to it. Everything's looking good. I'm checking the source code I've modified here so that when the end user authenticates, they will be routed to our custom HTTP server to capture all credentials from the spoof login page. And let's just close out these windows. Next, I'm going to begin poisoning both the mobile device as well as the default gateway using ARP spoof, followed by enabling DNS spoof on my mobile device and run the browser to query for yahoo.com. If you're wondering why the screen is black, it's due to screen recording security that is set in place to prevent sensitive data from being captured. and then I'm going to enter yahoo.com, and then I'm going to switch to my keyboard for my mobile device, and I'm going to enter the actual credentials and post them. And as you can see here, the exploit is successful and the credentials have been captured. You can see the credentials right here in HTTP logs. How to protect yourself. Check if the connection is secure. One of the biggest dead giveaways to knowing that you're on a rogue access point is the classic lack of HTTPS for sites that typically have them. Be mindful, just because a site has HTTPS doesn't mean it's secure. Check for more than one of a kind. If you happen to notice multiple access points that are of the same name, then that's a dead giveaway that you might be in range of a rogue one. Simply refuse to connect to either and you'll be safe. The GUI of your IoT device will show you this. If this happens to be your home network, simply connect physically to your access point and change the frequency channel and name of the BSSID. If you have the option to enable randomization of the frequency channel, then do so, as it prevents threat actors from honing in on your AP. Turn AutoConnect off. Turning off AutoConnect prevents you from auto-connecting to a rogue access point, more so if it's a home personal network which you trust. This also factors in what I've talked about in regards to more than one of a kind. Let's say, for example, that you have a secure access point and a threat actor is trying to bounce you to theirs, which is passwordless. If you simply turn off AutoConnect, not only will you be able to spot duplicate access points, but you can tell the difference between the two, the difference being that yours requires a password while theirs does not. You can then apply the quick remedy I mentioned to resolve conflicting BSSIDs and frequency channel randomization to neutralize this. Fun fact, hackers could get around this by simply hiding their AP BSSID from being scoped out. What isn't useful for security does in fact aid hackers. So give it some thought. This is a game of chess after all. Creating a rogue access point. Although this isn't part of the main exploit, here's a step-by-step little video on how to create your very own rogue access point. This is a bonus gem that I felt I should show since most people don't teach this. In Linux, it's possible to turn one of your NIC interface cards into a working access point. Essentially, you're making your own homemade little router, and all with a simple configuration file that you can set right here. You'll be able to find a full video up on my YouTube channel, which you can further watch after this presentation. But since we are good on time, I'm going to show you the video anyway. In this video, I'm going to be showing you how to create your very own rogue access point using the NIC card interface on your system. First, we're going to pop open the current file and use Nano to copy the configuration files that are needed for it. If you don't know what Nano is, it's basically a terminal-based text editor. Next, we're going to add the following line of text to the file, bridge equals 0, which is going to turn an NIC card on our system into a bridge, which is another term for a gateway device. Next, we're going to rinse and repeat and do the same for the DNS mask configurations, so that when we enable DHCP, Dynamic Host Configuration Protocol, it's going to allow our access point to assign IP addresses to devices when they connect to the network. And we're going to check if everything is there, and it's good. Next, we're going to run the following command, which is going to allow us to assign the default gateway IP to the access point itself. This is so that devices on the network know where the exit node is, which handles traffic on the network itself. We are also going to assign a subnet to it. Next, we're going to configure the IP tables for the access point via the command iptables. Last, we're going to run the two commands in order, DNS mask and host APD, which will configure the DNS mask for us for the DNS server, followed by the host APD, which will initiate the access point for us. It is very important that you do this in order. Full access point is set up and we're good to go. Thanks for watching.